Hello and welcome. In this video lecture, we will learn an algorithm to do the decimal to binary conversion. The question, however, is why we need to learn another algorithm to do the decimal to binary conversion anyways. Simply put, it gives us more control on the output. Sometimes we need to visualize a register value, which is usually 8 bits. However, the string constructor would assume that the leading zeros are not important and ignore them. These bits usually indicate unset flags, and it is nice to visualize them in a way that makes us focus on the problem we are solving, rather than spending a moment trying to figure out which bit is which. The algorithm is very easy. We keep on dividing the number by 2, and at each step we take the remainder, which is either 0 or 1, and use it as the next bit. The first digit is the leftmost bit. Let's start Arduino IDE and implement it. And now we start an empty Arduino IDE sketch file, and let's define a new method, just like we did in the previous lectures. That returns a string, and let's call it decimal to binary. And let's pass unsigned long value. Let's begin by defining the size and the array buffer. But instead of 8 bits, we'll use 9 bits. I'll tell you why shortly. Then we define the array itself, character pointer buff equals new character of size. Now you may be wondering why I'm not using memory allocation from C language or any other notation for creating the array. New is the new standard for allocating and freeing memory in C++. So it's always a matter of preference. If you are using malloc for allocating memory, then you are bound to make mistakes. If you are using the new C++ way of doing it, you are more likely to make less mistakes. So I also wanted to introduce to you another way of doing it, so that you learn that there is not only one way of doing things, but there are many unlimited ways of doing things, and it's always a trade-off, and it's always a matter of preference. At this stage of learning, you must be aware of almost all the techniques and their pros and cons. Now we'll initialize the array to contain zeros at the beginning for unsigned integer. So we create a for loop, and then we create unsigned integer variable. We name it j, we initialize it to 0, and we let it loop until size -1, and then j++. So that will loop over all the bits of the array except the last one. And over here we say buffer of j equals 0. Note here that we are using a character notation with the single quotes. Now let's create another loop counter. Unsigned integer 8 underscore ti equals size -2. So that will loop from the left side of the array except the last bit once again. You may be wondering by now why you are always skipping the last bit. It will become very clear shortly. And then we do the while loop. This is actually the algorithm we are implementing. While value is greater than 0, then we make a condition: if value modulus 2 is not equal to 0, then we initialize the array buffer at this point to equal 1. Now we do the division part. So we have done the modulo, the value modulo 2 part. Now we need to do the division part. So we could simply type down value equals value over 2, and that would be extremely fine. We could also do it like this, and that would also be extremely fine. But I would like to show you as many ways as you can, so I will do it like this. And that's exactly the same way of saying that value will be divided by 2. Remember from a previous lecture we introduced the bit shift operators, and the right shift is equivalent to dividing by 2, the left shift is equivalent to multiplying by 2. It's most commonly used in embedded systems, so you must not be intimidated by this notation, and that's why I'm using it in this context. And finally we decrement the variable for the loop counter. Now it's due to know why we left or skipped always the last bit. The strings in the C and C++ languages are null-terminated strings. That means they must end with a special character to indicate the end of the string. Otherwise, there will be a runtime error and the compiler or the runtime environment will not render the end of the string correctly. The end of string, that's why, will be made like this at the end of the buffer, at the very last index, size -1, and this is the special character or the null termination. \0 single quotes. That's it, and this way our string will be processed correctly. Finally we return the buffer. Now let's head over to the setup method and call this function serial.begin 9600, then we type a string str equals decimal to binary, and then we pass the value 134 just like the previous lectures. .println string. But to make it more interesting and also to see why we really did it that way, let's try another value that will have leading zeros so that we can demonstrate the use of this method. So str will equal this time decimal to binary of 23. Just an example, try anything you like. Then serial.println str. Let's save. Let's upload. Now let's run the serial monitor to see what we have got. Okay, here we have got. So now you can see that the two values, they are indented the same way, bedded the same way. It's visually appealing and it is very convenient to tell which bits are on and which are off. That will become very handy when you are debugging register values, flags, and all these kinds of things related to embedded systems that we shall encounter along the way. Thank you and see you in the next lecture.